Welcome. Today we'll be presenting to you the mental math machine. My name is Maxwell Stonham,
And I'm Dylan Cazares.
and we will now begin our presentation.
And what is the Mental Math Machine? Well, the Mental Math Machine is a game that utilizes the DE2 board to display simple multiplication and addition problems for the user to answer within a certain time period. The purpose of this is to teach and challenge young children to train their mental math abilities within a short period of time.
So a quick project overview on what the mental math machine is that we're implementing it on the DE2 board with no external devices. So we're not using an external keyboard or mouse, we're just using everything that the board comes with, such as the LCD screen, to display the math questions. So there'll be 3 rounds per game. Per round, there will be 9 questions. And per question, the user gets 10 seconds to answer. What we've also implemented is a performance tracker. So with the performance tracker, we get to gauge how difficult the next round will be, or whether or not the user even passes the next round. The difficulty increase will go from easy, medium, to hard, depending on how well the user does in the previous round. The user will use inputs such as the switches and push buttons to answer their questions. And the outputs will, of course, be the LCD screen, as previously mentioned, along with the 7-segment display. The challenge for this game is that the user inputs are going to be in binary, and we will get into that later on in the presentation.
So the overall system of this game is the main part, the DE2 board, which includes the inputs and outputs of. So the inputs include the switches and push buttons, and the outputs are the LCD display and the 7-segment display. So the submodule includes the LCD screen, which is used to display the math questions, and another part includes the switches, which is used for the user input. Another part includes the push buttons, which is used to submit the answer. And another part includes the 7-segment display, which is used for the tally, timer, and displaying the user input. So the timer is implemented via a counter to decrement each second. And for the tally, similar to the timer, it utilizes the counter to increment each time the user answers a question right or wrong. And the performance tracker is implemented using if and else statements based on the tally. So the difficulty increases if the user answers 6 out of the 9 questions correctly.
So this is the block diagram for the submodules that Dylan just presented. So the random number generator is fed into the DE2 board, and this allows the question to be displayed onto the LCD, along with a welcome message at the start and a prompt on when to start the game. So the DE2 board, after the question is displayed, the user inputs will either be the switches or the push buttons. Now, how the switches work is, as I previously mentioned, the inputs will be in binary, and we will only have a maximum of 3 digits per question. So, for example, 15 times 15 is 225. So if the user were to input that, the user would have to use switches 8 to 11 for the first 2, switches 4 to 7 for the second 2, and switches 0 to 3 for the 5 at the end. Every time a user flips a switch, the 7-segment display will output what the user inputs. So for example, if I were to input 48, I will be using switches 4 to 7 to input 4. So it'll be 0, 1, 0, 0 using switches 4 to 7. And 48, so switches 0 to 3, I'll be using 1, 0, 0, 0. And that's how the user will input their answers. And this is just a quick overview on the 7-segment display and what the signals we'll be using for the tally counter, which is hex 4 and 5, to tally the right or wrong answers. hex 2, 1, and 0 for the digits I just previously mentioned, hex 6 and 7 for the countdown timer, and for each switch that the user inputs, it'll display on the board, on the 7-segment display, and to submit their answer, they would have to click key 0. And all this is done within 10 seconds. So after the switches are used, push button, next question. Question displays, switches, push button, next question. All till the round finishes. And the performance tracker is implemented as shown. Stage 1 will be the easy difficulty. And if they pass, they will go to stage 2. If they fail, they will game over and restart. All along to stage 3, and then after they get to the hardest difficulty, the game ends. And that's the overview for the block diagram. So, as a conclusion, we learned quite a lot during this project and encountered many issues. Dylan, if you would start.
So some of the issues we've encountered was trying to deal with the 7-segment display. So I'm lumping the timer and tally-in together because the issues were quite similar in that we tried to assign the output of the counter and the timer, which are pretty similar and mapping them out onto the 7-segment display. And for the 7-segment display, it needs a data input, which ranges from 3 to 0, and for our output of the counters, it really didn't map out too well.
Other issues we came across was the VGA and keyboard. The reason we resorted back to the LCD and switches was because we couldn't quite figure out how to implement this in an efficient way. So for the VGA, the easiest way that we figured out how to do was to read off different text files. And we thought that was quite inefficient and complicated considering we were doing a random number generator. So we couldn't quite figure out how to generate random numbers onto the VGA by reading off different text files. We thought initially, when we proposed the idea, it would just be as easy as a cout or a printf, but it turns out that wasn't the case. Dylan, keyboard difficulty?
So the keyboard difficulties we had were trying to map out the keys to the user input. So we tried to, so if the user clicked the number 5, it would output the number 5 on the 7-segment display. So that was our issue there. I'm trying to map out the 7-segment display with the input of the keyboard.
So LCD difficulties as well. The way we tried to use the LCD was by taking advantage of the software that was downloaded onto Quartus, which was Neos 2 and Eclipse. And by using the software, we thought we were able to use the C and C++ compiler to at least print any sort of display. But even that didn't work because there were compilation errors that we weren't able to quite resolve. So that proved to be another hurdle in our project.
And another difficulty we had was the switches, and again also involving the 7-segment displays, where our initial proposal was to have, let's say, switch 5 being the number 5 on hex 3. However, that's not really possible, or we don't know how to correctly implement it, because the only way we knew how to implement, let's say, a number was to use 4 switches, and that really didn't go well with our initial proposal.
So for the random number generator, we spent a lot of time implementing it into ModelSim and spent a lot of time perfecting the simulation in the test bench. However, we forgot that, we realized later on that implementing it onto hardware with Quartus was totally different because we didn't take into consideration that simulation results or simulation code would not transfer well into Quartus. So we spent quite a lot of time on the test bench having that work well and having issues with generating numbers onto the board. The performance tracker was tricky at first because we tried to, again, we spent a lot of time on the test bench rather than onto the the code for the board itself. So that was kind of the same issue we were having. And in all, in conclusion, we've realized that it's much easier to simulate onto Model Sim than it is to download code onto the board and have it work onto hardware. So that was mainly our issue.
And well, the project was it's an easy concept. However, it was quite difficult for us to implement.
Yep.
And thank you.
Yes. Thank you very much.
Hi, my name is Maxwell Stonham. I'll be presenting my CP 200 lab demonstration for me and my friend Dylan Cazares, but due to COVID and safety reasons, he will not be performing this demonstration with me, so I'll be doing it alone for safety. So, here's the workbench. Due to difficulties we had, we were not able to implement the random number generator onto the LCD display. Most of the difficulties were addressed in the PowerPoint presentation. So for demonstration purposes, we will assume that everything goes well. Everything works fine. Because we were not able to implement the LCD display alongside implement the 7-segment display for the timer and the counter. So that's where the timer is supposed to be, and that's where the counter is supposed to be. So we were able to do the user inputs, and that's what the demonstration I will be showing you right now. Assuming everything goes well, you turn the board on. There will be a prompt, a welcome message. Are you ready to begin? You would click the rightmost push button. This will act as an enter key. So you would click that, and a randomly generated question will pop up. So as the question pops up, timer starts to increment down by 1 second, tally resets at 0, 0. And for example, if a question prompted me to, so if it was 7 times 7, for example, I would have to answer 49. And keep in mind that the switches are in binary. So these 4 switches correlate to that, these 4 correlate to that, and these 4 correlate to that. So 7 times 7 pops up. I would have to do 49. So I would flip this one and these 2 switches. 49. Timer goes down. This is my answer. And to submit, I would have to click this. Push button acts as an enter key. 49 will be submitted. If that is the right answer, the counter will increment 1 on the right, which is this one, the right. And if it's wrong or I do not answer in time, the wrong tally will increment up. With each push button enter next answer, a new question will come up and the timer will reset. And this will go on for 1 whole round, which is 9 questions. And if the user gets 6 out of 9 questions correct, then they are able to move to round 2. Otherwise, they have to restart the game, and there will be prompts. Are you ready to move to round 2, or are you ready to restart the game? And you use the rightmost push button to either restart the game or go to the next round. So that's our demonstration. Thank you very much.